found inside the egg. The magnum gives way to the next section of the oviduct, the isthmus. Here, the shell membranes are deposited. These thin layers of protein wrap loosely around the albumin covering the yolk. It is as though the yolk and its layer of albumin are a blob of jello, wrapped with 2 sheets of cellophane. The process does not result in a smooth, egg-shaped structure. In fact, an egg leaving the isthmus probably looks more like a prune than a plum. The partially formed egg then enters the shell gland. Here, over the next 20 hours, the shell will form. First, a thin albumin is secreted. This thin albumin is mostly water, and it moves by osmosis through the 2 shell membranes into the highly concentrated thick albumin surrounding the yolk. This plumps the egg into a normal shape and stretches the shell membranes tight around it. Next, a highly concentrated solution of calcium carbonate is secreted by the shell gland, and crystals of calcite form and grow on the outer shell membrane. As the crystals expand, they grow into one another to form a solid shell. Very tiny spaces left in between the crystals leave pores in the shell. Lastly, a special protein solution, called the cuticle, is deposited onto the eggshell. Gas can pass through the proteinaceous cuticle and through the pores in the shell, but the 2 layers protect the egg from harmful bacteria. Finally, in a process called oviposition, the egg flips end over end. This occurs through contractions of the uterus, synchronized with relaxation of the muscular vagina, and pushes the egg out of the hen's body. An important part of the egg does not form until after